This is a demonstration of a pocket balancer. Here's the pocket balancer unit, and we've got a balancing rig set up here. And the first thing we would do is put a reflective tape onto the unit that we're going to balance onto the rotor, so that the tacho here can pick up the signal. This can be done usually with a bit of reflective tape, and the signal will be picked up by the tacho. Here you can see the RPM level is changing as I'm flashing this little bit of reflective tape in front of it. It can be stuck on the side of the shaft or on the front. Here we've set it up for convenience with a disc with a little cutout, so that we've got our strobe marker, and you notice this has been set to 0 degrees. So that's our reference point, and we'll be able to work out our angles relative to that point here, which is the tacho. You'll also notice that the tacho reflector point is lined up with the first accelerometer here, so they're both at 0 degrees now. Okay, so there's no phase difference between the point where we're reflecting and the point where we've got our accelerometer. Those are both connected into the pocket balancer unit through this 3-way splitter cable, and they go into the 2 black connections. It doesn't matter which is which, they're easily interchangeable. What is important, if you're doing 2-plane balancing, the second channel, plane B, this is plane A, plane B goes into the red cable. 2-channel balancing is something that will be the subject of a later video, and we'll show that then. For today and in this video, we're going to concentrate on a single plane balancing job, and we're just going to give a quick demonstration of the steps involved in running through that. Okay, here we can see the screenshot of the unit, the pocket balancer, which shows an opening menu. It shows a vibration meter, toolkit, etc. But the top left hand icon is the balancing icon. By pressing enter or by touching the screen, I can select balancing mode. And here I've got single and 2-plane balancing. I've got a toolbox that lets me do other things, and we'll come back to that later. But initially I'm going to do a single plane balance and select 1-plane balancing. Okay, just hitting the enter button will take me through the steps now. So I'm going to press the enter button on the unit to go through each of the steps in the balancing run. And the first thing I'm asked is whether I want to do a standard balancing run, which is any weight at any angle, or fixed points, where I have, for example, fan blades and I've got a limited number of positions to put the weight, or where I've got fixed weights and they're simply moved around to change the angle to do the balancing. Well, for this run we're going to do a standard balancing run, which means we can put any weight at any angle. Next thing I have to set up is the position, the direction of rotation, clockwise or counterclockwise. We're going clockwise in this case. And the phase key offset. This is usually set to 0, as I showed earlier on, when the accelerometer and the reflective mark are both lined up with 0 degrees. Turn the motor on this time and take a reading. Okay, this screen shows our initial out of balance vibration in millimeters per second and the angle of the heavy spot. And if I look on a graph, I can see that drawn in as a vector plot. The next thing to do is to enter a trial weight value and to attach a trial weight to the rig. So in this particular case, we're going to add a small weight. We're going to add 3 grams and I'm going to add it at 0 degrees. This is common practice when people are balancing. They usually put their trial weight at the actual reference point. The next thing to do is bring the rotor up to speed again, and when it's up to speed, collect the data. And we can now see the effect that the trial weight has had in that it's moved the heavy spot. Not by very much, but it's enough to calculate what we now need to add as a correcting weight. The next thing I'm going to do is tick this little box in the bottom corner here to say leave the trial weight as it is and just add a balancing weight. And it's now telling me to add 9.79 grams at an angle of 89.59. Okay, so we need to weigh out a balance weight. Okay, we're adding 9.8 at 90 degrees. Next thing we do is bring the rotor up to speed. And having brought it up to speed, take another reading. And what we find is that the vibration, the out of balance vibration, has been significantly reduced. And if we look on the vector plot, we can see that we're heading towards the centre. Okay. This actually meets specification and our vibration level is within what we require, but just to illustrate the process, we're going to do a trim run. By selecting trim, we're going to enter some details of a trim weight, and the pocket balancer is telling us to add approximately 3 grams at 187 degrees to trim that. I'm just weighing out 3 grams. Interesting to note, angles are always measured against the direction of rotation. So here's our 0. We're going to add this trim weight at 187. There we go. Final step, run the motor up to speed. Get the reading. And as you can see, we've improved things slightly. We've brought the out of balance in closer to the centre and reduced the vibration from an initial 2 millimeters per second down to 0.4 millimeters per second, which is a very good level really for a rig this size. Save that balancing run. If I select save, I can get an automatically allocated file name telling me the balance job with its date and time. I can edit that, put details in, say this is John's run testing the balancer, for example. Okay, that's all saved. Last thing to do, exit. Exit balancing run. Okay, that's all there is to it. The thing's balanced. Finally, here's a demonstration of the Pocket Balancer report generator. This software runs on a desktop PC. We can load in the balance job. It can either be on the Pocket Balancer unit itself or on the desktop, depending on where we saved it. So here we select the balance job by its date and time, and we've got the information, both the details and the vector plot showing the balancing run. We can put in a logo, and if we just select a logo, it will be added into the report. And we now have a document ready to print showing the details of the balancing job. And here we are, sending it to the printer.